So when we're working with circles, our general equation is x minus h quantity squared plus the quantity y minus k squared equals r squared. And there's parts of that that we can pick up to understand parts of the graph, which is what we're actually talking about in number 2. Explain how to find the center and radius, okay? The center of your graph is going to be located at the points hk. Now here's the part that's tricky though. Notice in the equation part it says x minus h, y minus k. So when you're trying to figure out these parts, you're actually thinking about the opposite of what you normally would. And I'm going to put an example down in a minute to explain this. Your radius is basically going to be the square root of your solution, or your r squared that you have on the right side of your equation. So when I'm trying to figure this out, when I'm given a general equation of a circle that actually have the numbers in it. So for instance, let's just say I had an example of x minus 3 squared plus y plus 4 squared equals 16. And I was asked to find the center and the radius. Well, as I'm looking at that, my initial inkling might be to write, -3 and +4, or my center. But it's not, because remember, it's x minus h. So I'm subtracting +3. So my x value would be 3. Now here's the one that's real fun. My k, if you minus a negative, this is really the equivalent of having y minus -4. So basically what the rule I like to look at it with my center is, it's the opposite sign of what you see. If I see a negative, it becomes positive for my center. If I have a positive number, it's going to become negative. So the center of my circle would be at 3, -4, and then my radius would just be the square root of 16, which would be 4. That's the two basic bits of information that we're looking for most of the time on these. So it's nothing too terribly awful. It's just getting used to the form and the little twists that it can tend to throw in. So when it says write the equation of a circle with a center at the origin, 0, 0, and radius 5. Now if you really want to stick to the form, we can. We could do x minus 0, because again, this is my h and my k value. So x minus 0 squared plus y minus 0 squared equals my radius squared. But I always want to simplify if I can. Well, taking nothing away from x really means I didn't take anything at all. So I'm just going to write that as x squared. Again, could I leave it like that? Sure. But normally, if it's 0, we don't put it. And then 5 squared is 25. And I'm ready to go. Now this is where, and again, we're going to do lots of these to kind of get some practice. But this next one gets kind of more interesting. Write the equation of the circle if it's shifted 4 units to the right and down 2. Okay, here's normally how I would look at that. I'm like, okay, my center was originally at 0, 0. My new center shifts 4 units to the right, so I'm going to add 4 to my x value. But it shifts down 2, which would be my y value, so 0 minus 2 would be -2. Now notice the size of the circle, its radius doesn't change at all. Just the center. So when I go to write my equation, again, it's x minus h squared. So again, it's like the opposite of what you see, plus y minus -2. and minus a negative will make that plus squared. But my radius is still 5, so this is still going to be 25. And I'm ready to go. So no worries, it's just kind of understanding the shifts. And again, if it means taking your old center and then literally adding or subtracting to figure out your new x and y values, that's okay. So sometimes they'll give us a little more information, which is always nice. Okay, identify the center and radius of each, then sketch the graph. Okay. Well, let's see. I don't see any pluses or minuses here, so what's my center going to be at?
Origin.
At the origin, because if you don't see pluses or minuses, we assume they're zeros. It kind of works the same way number 3 did up here. So my center is going to be at 0, 0. What about my radius? 3, because it's the square root of 9, which is 3. So here's how I think is a good way to do it. A radius is from the center to the outside edge of your circle. So from my center, I'm going to go 3 units in each direction and then attempt to make my circle plane connect the dots. And if it's not perfect, don't worry. If you get more of a little bit of an oval shape sometimes, or it's a little bit lopsided, it'd be more like a flat tire than a circle. But that gets you the general idea of what this is going to end up looking like. And the biggest thing with these is just being able to look at them and figure out that center and that radius. Because if you can do that, that's the part, this is the part that shows up in standardized testing. Not the graphing, but can you figure out where the center or radius would be? What's my center going to be in number 6? Okay, right. Just think opposites. 4, negative 3, and then what about my radius? Square root of 4, which is 2. And then again, the order is going to be the same. Plot your center first. So right 4, bless you, and down 3. And my radius is 2, so I'm going to go 2 units each direction. And make myself a circle. Any issues so far? Because we're kind of just getting ourselves used to this whole idea. All right, let's see. What about my center in number 7? Negative 1, 3. Opposites there, because again, the minus kind of makes that opposite. And then my radius is just the square root of my solution. So again, left 1 and up 3, get a dot. A radius of 3. So we'll go 3 out each way. And again, just look for the little things that they try to throw in to throw you off. Like number 8. One of them's parentheses, one of them isn't. Where is my center? Nice, okay. Opposite here, negative 3. And again, anytime you don't see the parentheses with a value after, we assume that coordinate's going to be 0. So negative 3, 0, so just left 3. My radius is going to be 4. Okay. Any issues so far with center and radius? Because again, we're trying to be straightforward as we can be here before we get into some shifting around a little bit. No, it's not terrible so far. All right, let's flip over and see what else we've got in store for us here. All right, use the information provided to write the standard form equation of the circle. Okay, to do this, I need the center and I need the radius. So where is my center located? -2, -4. And how far is it from the center? How many units is it from the center out to an edge? 2. Okay. So now I'm ready to write the equation. So again, it's x minus h, but again, basically it's the opposite of what I see, so it's plus 2 squared plus y minus k, so minus -4 makes that plus, squared equals my radius squared. And that would be my equation. So that's our big challenge as we go through with any of these, is to find that center point. Get that jotted down first. So this one looks like it's at 0, 1. And again, I'm just trying to see what my radius is going to be so I can get that last solution type answer. And again, if you have 0, I would just write that particular variable squared. But again, it's not wrong if you put x minus 0 squared. Positive 1 will become minus 1 and square my radius. And if they're nice enough to give us the center and the radius without it, well, that's even better. Because you're like, okay, center 0, 0. Here's my h and k. I don't have either of them, so it's just x squared plus y squared. But don't forget to square your radius. So we'd have 64. So you're kind of at a point now, you're like, okay, this is easy. I'm just kind of rolling here. X, switch the sign, plus y, switch the sign, and square my radius. Then all of a sudden, we come to a screeching halt. Uh-oh. They give me the center, and they give me a point on the circle. Well, I don't know if that's really going to help me or not, because, yeah, I have the center, but how am I going to figure the radius out? I mean, shoot. So I might, if I'm really confused, I might sketch myself a quick little graph to try and think about this for a minute, because it might do something to help me out a little bit. So let's just say, you're like, okay, if I go right 8 and down 15, you're like, you're not putting any lines. Don't need them, because I'm just going to kind of use this as a sketch. If I were to make this a triangle, I'd be 8 units over. I'd be 15 units down. And again, I'm thinking about distance. I can't have a negative distance to a side of a triangle. Let's see how much stuck from geometry last year. How do I find x? Yeah, we're going to use the Pythagorean Theorem. Now, if you know your Pythagorean triples, that's even better. It makes this easier. But if you don't, there is still hope. So basically what I'd be looking at here is I'd be looking at 8 squared plus 15 squared equals x squared. I've got to figure out what that x value is, because that's what my radius is going to be. So let's see here. 64 plus 225 is 289. And I believe that's 17, but we'll come back to this in a minute. Would be my radius. You're like, but wait a minute. I'm just going to re-square it. Doesn't it come back to this? Yes. But again, being able to get my radius is never a bad thing. So you're like, okay, so what's this going to look like? Well, with my center, it's still just x squared and y squared, just like it was in number 11. And then I just square my 17. That's a really big number. Well, it's kind of a big circle, to be perfectly honest. So it kind of works out kind of nicely for us. And so that's what I would be doing on each of these each time. you've got options. If it comes out something with a nice center like that, I can use the Pythagorean Theorem. You're like, well, not everyone's going to come out in the center, is it? No. So what do I do then? Well, now we got another geometry thing that comes in. You're like, dang, thought I was done with geometry. We're going to use the distance formula to see how far it is from the center to the edge of your circle. So here's how we're going to do this. Remember, to find distance, I've got the difference of the x's, and I square that. And I take the difference of the y's, and I square that. And this is going to let me know what my radius is going to be, how far it is from the center to the outer edge of the circle. So I go, okay, so my x's are -10 and -8. So I've got -10 minus -8 become plus. And then for my y's, I have 14 minus 11. And once I get this value, so I've got -2 squared and 3 squared. You're like, Harty, that's like the square root of 13. Yes. You're like, I can have a square root be my radius? Yes. Okay? You're not always going to have a radius that comes out whole. It can be a decimal or a fraction. So here's what the equation is going to look like. Still going to do it the same way with my center. X, switch my sign, so plus 10 squared plus y minus 14 squared. What happens when you square a square root? Yeah, they're opposites, they're inverses. So they're just going to cancel out. And I end up with just 13 there. And that's okay. Yeah.
Wait, how did you get your diameter and radius being the same number?
Okay, that's just D. That's for distance. That doesn't stand for diameter, so I'll get that on my way. Yeah, that's just my radius. Let me start using R here instead of using D for diameter. Because you're right, I could see how that, instead of thinking distance, you're thinking it's diameter. I'd be confused too. So the last possible twist might be given the center and the radius. Might be given a center and the point on the circle, and we need to find how far that is. The last issue we can run into is, what if we're given the endpoints of a diameter? Well, this is a little mini two-step process. One, if I find the midpoint of the diameter, that would be my center. Because if you think about a circle, if you know the diameter, 2 of the edges, and you find the spot in the middle, that'd be the middle of my center. And then 2, to find the radius, that would be the distance from the center to one of the endpoints. So this is going to be a two-step process to get us to the answer. So they give us the ends of this diameter. We're just going to do 2 pieces and we'll have it. Midpoint, remember, you just add up your x's, divide by 2, add up your y's, divide by 2. So we've got 20 divided by 2, which is 10, and 16 divided by 2, which is 8. So that's my center. Now, you may think, okay, so I have my center and I have endpoints. Does it matter which one I use with the center? And it doesn't. Okay, if you think one's going to end up being easier, that's okay. So in my case, I'm going to use these two for my center and my endpoint to find my radius, but I'm going to use the distance again. So to find my radius, subtract my x's and square, so 10 minus 2 squared. Subtract my y's. And then I'm just going to crank this guy out. So let's see. 8 squared is 64. 8 minus 2 is 6. 6 squared is 36. And we're going to get one that comes out nice this time. You're like, all of that just to get, now I still got to write the answer. It's true. So now to find the answer, again, these are the values I put in for h and k. So x minus h squared plus y minus k squared equals my radius squared, and 10 squared is 100. So all I'm attempting to do here is I got to take the information they give me and kind of use it. Don't freak out with the ones at the bottom, because like we said before, if I looked at this, let's forget that it says translate here. Where's my center at for number 18? 1, 1. Okay, so if my original center is at 1, 1, and it translates 4 to the right, my x value is going to go from being 1 to being 5, because I went 4 to the right. Think of it as a picture. If you need to sketch a graph, that's okay. And then my y value goes from 1 and is 3 down, which means it's at -2. The radius is not changing. So this is the one I'm going to use. X minus my h squared plus y minus my k squared, which changes the sign, but the 64 is still going to be the same. Now, depending on what you've got going, how your pacing works, how quickly things go, here's what I am going to do. There is a review for this quiz that is going to be coming up. Okay? Quiz is going to be on Wednesday. So, what I'll do is I'll hit pause.